Okay, folks, as always, put a red X on the number that's wrong, write in the correct answer in red. Number 1 is 19. 19. Number 1, 19. Please just focus on the paper you're grading. Number 1, 19. Number 3 is 8. 3 is 8. Number 4 is 38. 38. I know some of you are grading 2, so I'll try not to go too fast for you. Number 7 is 15. 15 for number 7. Number 9 is 6. Number 9 is 6. Number 10 is 19. 10 is 19. Okay, so 1 is 19. These are the answers. If they don't, mark it wrong, write the correct answer. 1 is 19, 3 is 8, 4 is 38, 7 is 15, 9 is 6, and 10 is 19. Okay. 19 is 2, 2, 4, base 5. You got to show that base 5. 2, 2, 4, base 5. You wouldn't say 224 base 5. It's 2, 2, 4, base 5. That is the correct answer. If they don't have it, write it in, please. Number 22. 3, 1, 3, 2, base 5. 3, 1, 3, 2, base 5. Number 25, 1, it looks like 4 zeros, 0, 0, 0, 0, base 2. 1, 0, 0. Is there 4 of them? 1, 2, yeah, 4 of them. 1, 0, 0, 0, 0, base 2. 26, 1, 0, 0, 0, 1, 1, base 2. 1, 0, 0, 0, 1, 1, base 2. 39, 3013. No base there. We're back in our normal base 10, 3013. And that makes number 40. 504. Very good. 504. Number incorrect at the top. Pass it back to an owner if the owner's here. If the owner's not there, hold on to it. Yes.
For 22 and 25, what is with commas?
Just disregard. Just cross them out for them. Just cross them out for them. So one time we won't use the commas because it's not really a number. That's okay. The bases, though, you have to show. Any grading questions, anybody? Abe? Okay, questions over 1 through 10. 1 through 10, how to get the values in converting from, what do we do, base 5 and base 2, mostly into base 10. Any questions 1 through 10? Everybody's good there. Okay, so that's the one way. Then what happened in 19 through 26, we went the opposite direction. Questions on anything 19 to 26. 19 through 26. Anybody? 19 to 26. No questions? Everyone's good? All right, 39 and 40. Lauren? I'm sorry, LC?
39.
39, all right, so here's what 39 looks like. 39 says BC5 base 16. All right, so everybody has to understand, first off, this question is like 1 through 10. we're taking a different base and converting it to our base 10 system. So that's the first thing you have to understand. And Lauren, the way that starts is you start with the exponents. 16 to the 0, 16 to the first, 16 squared. I only need 3 because there's 3 places. Okay? Now remember, we're going to figure out what the value is. 16 to the 0 is a 1. 16 to the first is 16. And what's 16 squared? Somebody have that number? Say it if you know it. 256? Okay. So again, you would do 16 times 16. Now remember, Lauren, at this point now, you need to add, and you have to multiply times the place value. So the first place was a 5 times the 1, right? In this second place is going to be the value of the C times the 16. And in the third place is going to be the value of the B times the 256. Now, you have to know what a B and a C is. So this is base 16. There are 16 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They also have a 10. We can't show a 10, or you'd think it's a whole different number. We can't show an 11, or you'd think it's a whole different number, or a 12, or a 13, or a 14, or a 15. So we use letters. And if you would look at the text would tell you that an A is the 10, right? Our base 10 system has 0 through 9. That's our 10 digits. The next one is a 10. The B is the 11. The C is a 12. You didn't use D, that's 13. You didn't use E, that's 14. And you didn't use F, that's 15. So you look over here, and next is C, and C is a 12. And you have to multiply 12 times 16. The last digit is a B, and a B is an 11, and you must multiply 11 times the 256. Now you have to multiply all that stuff out to finally end up with the 3013. So this is 2,816. This is 192, and this is 5. And when you add it all up, you get the final answer of 3013. Okay? So same concept, but we have to use letters for any digit 10 or above because our base 10 system. So let me watch up there again. Look at the BC5. Look what would have happened if you tried to use the digits. Don't write this. What was a C? A C was a 12, and a B was an 11. If they gave it to you this way, you'd think it's a 5 times 16 to the first, 2 times 16 squared, 5 times 16 to the 0, 2 times 16 to the first, 1 times 16 squared, 1 times 16 cubed, 1 times 16 to the fourth. You wouldn't know anything else. Because again, this is one number and this is one number, and therefore you got to use the letters because our system only has 10 digits. All right, that's exactly the same way you'll do number 15, although what was the base in 15? Or number 40, what was the base for 40? Oh, it was still 16. So what was it? Here you had an 8, and then you had an F, which was here would be a 15, and then you had what, a 1. So 1 times 256 plus 15 times 16 plus 8, and that's how you got the 504. Any other questions over anything on this lesson? Anybody? All right, great. Pass it. Okay, so 1A, 1B, 2A, 2B, and stop. Don't go ahead, please. Okay, those watching at home, you may want to pause the video if you want to have time to do these and work on at home. Okay, anybody want to give me the answer to 1A? 1A. Raquel?
A n equals a sub 1 plus 15 n minus 1 times b.
Not quite. Not quite. Eduardo? Okay, and it's n minus 1, so a sub n minus 1 plus d. That is the recursive formula. So who can give me 1b? Who can give me 1b? Cole? That is the explicit. 1b is the explicit. So I tried to give it to you as easily as I could. So number 1a would have to say a sub n minus 1 plus d. It's the only answer for 1a, and the only answer for 1b is explicit. Okay? So that's the way that goes. 2a. Is it divisible? Yes or no? LC?
No.
LC. We have an echo. It is no. 2a is no. I'll tell you why in a minute. Answer to 2b. Gabe, answer to 2b?
Yes.
Okay, and both of those are correct. Can somebody explain why 2a is no? Why is 2a no? Abby?
Because you have to add up all the numbers and 14 is not divisible.
Perfect. 1 and 7 is 8, and 3 is 11, and 3 is 14, and 14 is not evenly divisible by 3, and so that's why it's a no. Why is 2b a yes? Can somebody explain why 2b is a yes? Jordan?
Because when you divide it by 7, you get a number without a number.
Correct. You literally have to divide this one in. Long division for 7. 7 goes into 7 once. 7 goes into 7 once. 7 doesn't go into 5. 7 goes into 58 8 times. It's a 56. 7 goes into 21 3 times, no remainder. Right? And that's how you're doing that one. Okay, divisibility rules for 3, for 9, for 4, for 5, for 0, for 2, but 7 you're going to have to divide it in and see if you get no remainder. Andrew, question?
It's not about this, but
All right, then don't ask it right now if it's not about this. Okay. All right, 3 and 4. Go ahead and do 3 and 4 and stop. Go ahead and do 3 and 4 and then stop. I'll show you how to get the answer in a moment. Who wants to give me the answer for number 3? Antonio? 126 is the correct answer. Remember, the GCFs will multiply them out. I'll show you the factors in a moment. And who can give me the answer for the LCM? Adam? Real close. That's a 2 squared times a 3 squared times a 5 times 7 times 11. Is that what you meant? Okay. Good. So you had it correct, just said it wrong. Okay, so let's look back at the chart and let me refresh your memory as to how you solve these. Remember, some of you get all out of order and it's an issue. Sam and Andrew, I'm reviewing. I don't know why you guys are goofing off. Okay. By the way, this is live and that's heard now on the video. So, you want me to explain it to you? I'll explain it to you if you need me to, but you don't need me to. You want me to explain it to you? Come see me after class, I'll explain it to you. Okay, so the 2 squared times 3 squared times 7, some of you guys mess up your chart and you get factors out of order. Don't get them out of order. I left a space for my 3 and 5 knowing my bottom number had those. I want to keep my factors in order. GCF, you have to include factors where they both have it or all of them have it. They all have a 2, they all have a 3, and they all have a 7, and that's it. They all have a 2, they all have a 3, and they all have a 7. Oh, and I missed a 3, didn't I? Thank you. Yeah, don't miss any of your factors. You're going to get a wrong answer. There's one more 3 there. So a 2 times 3 times 3 times 7, you'd multiply that out. That's the 126. The LCM, remember, all the columns get represented. Whether there's all the factors in there or not, as long as there's a factor in the column, that factor gets represented. We're going to write those in factored form for time's sake, exponent form. 2 squared times 3 squared times 5 times 7 times 11. How many got both of those correct? Okay, good. All right, let's go on. Let's do 5 and 6. 5 and 6. You'll find 6 to be easier than 5. You might want to do it first. Do 5 and 6. Okay, let's come on back and take a look at where you're at. I'm going to do 6 first myself. All right, for the arithmetic sequence, a sub 1 is 3, d is negative 4. Write the first 4 terms. So you should have started out with that 3. That's the first. The common difference, right, says the next term is 4 less. So to get the second term, you would do 3 minus 4. That's a negative 1. To get the third term, you would take the negative 1 and go 4 less. That's a negative 5. And to get the a sub 4, you would take the negative 4 and go 5 less. And that's a negative 9. How many got that correct? Okay. Again, that should be the easier type problem. Now, I did give you a negative common difference. That's about as tricky as that problem can get. But you're at 3, go 4 less, negative 1. You're at negative 1, go 4 less, that's negative 5. You're at negative 5, go 4 less, that's negative 9. Jordan? You can, but just writing the terms out is fine. You know, we know that you understand a sub 1 is 3. So just list, it says write the first 4 terms. So I'm looking for a 3, negative 1, negative 5, negative 9. Any other questions on that one? Okay, anybody think they have the correct answer to number 5? Number 5. Alexandra? 500 and how many? 503. Anybody else have 503? Good job. 503. Okay, so looking at this, it sounds like Alexandra and all the rest of you that got that correct used the explicit formula. Remember, it is the explicit formula that allows you to find the value of any term. Now, you had the explicit formula right up there. I gave it to you, right? So I gave it to you. So it was there to be used. So now we just got to put in the values. So a sub 1, you know, is the 3, right? And that goes there. And we're doing the 101st term. So n is a 101. And the common difference you have to figure out, right? But you look and say each term gets 5 more, so that's a 5. Where do you end up here? A sub 101 equals 3 plus, I gave you an easy one, 101 minus 1 is 100, times 5, 503. Okay, it's the easiest way to do the problem. How many got that correct? Okay, and the rest of you, you're going to be aware of that, right, for tomorrow, and you're going to take note of that and say, oh yeah, I've got to do that explicit formula, gets me any term. Remember, the recursive formula only gets you a term when you know the previous one. So recursive will get you the next term, but not any term. The explicit gets you any term. Any questions on those two? Anybody? Okay, let's move on. Let's go ahead and do number 8. All right, number 7, not 8. We'll do 8 in a minute. Number 7. All right, for time's sake, see where you're at. Anybody want to try to give me the answer to this one? Nick? How many got 69? All of you correct people. All right, so, oh, I'm frozen here. So I wrote out the bases, 5 to the 0, 5 to the first, 5 squared. I only needed 3 of them because this is a 3-digit number, right? And then remember, I now have to multiply times the place there, so a 4 times the 1, and a 3 times the 5, and a 2 times the 25. So this is 50 plus 15 plus 4, and that's how you got your 69, right? Again, you got to do the 4 times the first one, the 5 to the 0, the 3 times the 5 to the first, and the 2 times the 5 squared, total of 69. How many got that right? Okay, decent amount of you. All right, well, if you didn't, let's get number 8 right. All right, try number 8. A base 2 system is commonly called what, Andrew? Binary. Awesome. Right, and binary is the code of computers. Ones and zeros. Ones and zeros. You done yet? Anybody want to give me an answer for number 8? Trying to pick somebody I haven't picked on yet. Pamela? How many got 26? All of you correct people got 26. Good. Awesome. All right, because again, you look through. I have 1, 2, 3, 4, 5 digits, so I need 5 2s, 2 to the 0, up through 2 to the 4th. Anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 times 2 is, I'm frozen. Thank you, Andrew. So 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 times 2 is 4 times 2 is 8. And 2 to the 4th will be 2 times that 8, or 16. Now I'm ready to go through and put my values in. I have a 0 times the 1. I have a 1 times the 2. I have a 0 times the 4. I have a 1 times the 8, and I have a 1 times the 16. Values. 16 plus 8 plus 0 plus 2 plus 0, 24, 25, 26. Questions on number 8. Madison?
So you wouldn't put the 26 base 2.
No, because we are turning it into a base 10 number. It's no longer a base 2 number. If this 26 in base 2 is this number, in our base 10, which is what we turned it into, is this number. Now, if you wanted to, you could put base 10, but we never put base 10 for our system because when we don't see a base, we assume it's our system. So we don't need to put the 10 down below. Okay? Did you get to 26? Did you get 26? Awesome. How many got 26 on that one? Okay, good. Let's go to the back and go ahead and do number 9. See what you can do with number 9. See what you can do with number 9. All right, who wants to give me the answer? Somebody raise your hand. And give me that answer. Let's see, calling somebody I haven't called on yet. I think I called on all of you. Wyatt, what have you got? Don't have it? Okay, let's see. Adriana, what do you have? Couldn't hear you? Don't have it. Veronica, what do you have? How many have 117? All you correct ones with 117. Okay, remember you need to start with your base. 15 to the 0. And I only have 2 digits, so I only need 15 to the first. That's all I need. What's the value of anything to the 0 power? 1. What's the value of 15 to the first? 15. Now I do my digits. What's a C? Remember, A is 10. B is 11. How do you know to start with A? Because 9 is our last digit of our base 10. And C is a 12. So I must do 12 times the 1. And then we have 7 as the other digit. Now you got to do your multiplication well. 7 times 15 is 105 plus 12, 117. Awesome job. How many got that right again? All right, good job. Good job. All right, let's try the last one. Write 26 in base 2. Write 26 in base 2. Anybody want to say their answer? Let's see. Somebody new? Alex? 11010 base 2, right? And that would be correct. 16 goes into 26 one time. Remainder 10. 8 goes into 10 one time. Remainder 2. 4 does not divide into 2. 2 divides into 2 once. 1 goes into 0, 0 times. 1, 1, 0, 1, 0, base 2. How many got that correct? All right, be careful. That's not hard if you can keep it straight. What did I tell you guys at the beginning of this chapter? Be careful. A lot of new things. How do you remember new things? You study them. You review them. You don't study them and review them. It could be an ugly test tomorrow. It could be ugly. So be careful. A lot of new stuff. Stuff that you haven't done ever before, and so you got to review it. You got to study it. Be careful. All right, the last one we're not going to have time to do. What would you do to find the LCD? You would find the LCM of the denominators. So a 12 is a 2 times 2 times 3. An 18 is a 2 times 3 times 3. And a 27 is a 3 times 3 times 3. What's the LCD? The LCM of the denominators? 2 times 2 times 3 times 3 times 3. So 2 squared times 3 cubed is the LCD, or 108. 2 squared times 3 cubed, or 108. That is the lowest common denominator. All right, I'm sorry that all your parents saw you guys all packing up while we were trying to finish reviewing. You were so anxious. I hope you'll get the question like that correct tomorrow, being you were so busy packing up. All right. Any other questions? Anybody on anything? Don't forget your previous test tomorrow. Andrew and Sam, I am talking right now and you are talking. Therefore, you're not hearing what I'm saying. You're also distracting those around you. Don't neglect your old test as always. Go back to the beginning of this chapter. Did I review every divisibility rule? No. Did I review factoring with a factor tree? No, I didn't have time. Will those be on there? Definitely. GCDs, GCFs, LCMs, definitely. Bases, yes. Sequences, arithmetic, yes. Geometric sequences, no. That was non-testable. The arithmetic was. Be careful. Any other questions, Kirsten?
So on here, would you leave it factored?
You can leave an LCD or an LCM factored. I would take it either way if I asked that question. All right, you're dismissed. Have a great night. Hope you do well tomorrow.